5.2, integration by substitution. We're going to have problems like these where we have a function times another function in our integrand. So we need to have a method on how to find the integral. So these are the steps that they tell you in the notes. So number 1, try to select u so that du is a factor in the integrand. Step 2, express the integrand entirely in terms of u and du. Step 3, evaluate the new integral. And step 4, express the antiderivative found in 3 in terms of the original variable. So you're going to rewrite this problem so that you can use those formulas we learned in the last section. Okay? And usually the trick is you see parentheses, and if you take the derivative of this one, we get this. So that's a clue right there. We want to let the u equal x squared minus 1. That way, when we take the derivative, and I'm going to write taking the derivative as du over dx. Okay, well the derivative of this is 2x. Okay, but we want to write our problem entirely in terms of u and du. So I'm going to solve for du here. I'm going to multiply by the dx. And then we can rewrite our problem in terms of u and du. Because our u, we're going to replace the x squared minus 1. And the du, we're going to replace the 2x dx. Okay, so we get the integral of u to the 5th, because we replace the x squared minus 1 with a u, and then there's to the 5th power. And then the 2x dx is the du. Okay, well then now we know how to take the integral. We just need to add 1 to the power and divide by that power. And then don't forget your plus c. Now we can't leave the answer like this because it wasn't in terms of u to begin with. So we need to rewrite our problem in terms of x. But we know what u was. It was x squared minus 1. So we're just going to fill that in. Okay, let's try another one. Same sort of idea in B. We've got the integral of the square root of 1 plus x to the 4th times 4x cubed dx. I see a 1 plus x to the 4th. I think that that looks good as our u. Okay, and of course if you pick a u and you take the derivative and it's not looking like it's going to work out, just start over again. You're going to get more and more used to finding which one should be your u so that you can continue your problem. Okay, so my du, I'm going to go ahead and just put the dx on the other side when I'm done. Okay. So the derivative of this is 4x cubed. Okay, well this one's working out nicely because 4x cubed dx is in our problem, so that's my du, and my u is the 1 plus x to the 4th. So let me rewrite my integral. I've got the integral of the square root of u because I put 1 plus x to the fourth. That was my u. And then all of this is my du. Okay, well, we can't use one of our formulas yet. We need to have this to a power, not be a radical, but we know how to rewrite that. So we've got the integral of u to the 1/2. Okay, remember there's a 1 right here, and there's a 2 right here. The 1 on the inside goes on top. The index goes on bottom. And now we can use our formulas from the last section. So we're going to add 1 to our power. So we'll have u to the 3/2 divided by 3/2 plus c. Okay, well, I can go ahead and multiply by the reciprocal instead of dividing the fraction. So I've got 2u to the 3/2 over 3 plus c, and then finally replace the u with what it was to begin with. So we've got 2 times 1 plus x to the fourth, all of that to the 3/2 power, all over 3 plus c. Okay, let's try one more. Part C, I've got the integral of 1 over 5x plus 4 dx. Well, the only expression I see in here, 5x plus 4, I'm going to try that out as my u, see what happens. So my du is the derivative of this, so I've got just 5 dx. But I don't see an extra 5 in the problem to substitute my du as 5 dx. Well, there's some tricks that you can do. Okay, so I'm going to first of all, I'm not replacing anything, I'm just going to rewrite my problem. 1 over 5x plus 4, and I'm going to put a 5 over 5 in here because that doesn't change my problem. That's just 1. I'm multiplying this times 1. That doesn't change the problem. But now I've got a 5 dx to go ahead and insert the du for. I just have this extra 5 in the denominator, which I can put in front of the integral. Okay, so I'm going to put that extra 5 that I have in the denominator here in front of the integral. And then I've got 1 over the 5x plus 4 was the u. And this 5 dx is my du. And now we know how to take the integral of that. Remember, the integral of 1 over u is the natural log of the absolute value of u. Okay, so when I rewrite this, I've got 1/5 ln absolute value of u plus c. Okay, and finally replace your u with what we let it be equal to in the beginning. So we've got 1/5 ln absolute value of 5x plus 4 plus c. So I've got more notes, more examples in the notes on Canvas. Check them out and try out the homework.